Hey everyone, and welcome back. Today, we are going deep under the hood of something you use pretty much constantly. We're going to demystify that incredible, lightning-fast journey your data takes from your screen all the way around the world and back again, all in the blink of an eye.
So, let's start with the really simple question. You're browsing, you click a link, and boom, the page just appears, right? It feels instantaneous. But in that tiny fraction of a second, an absolutely mind-boggling series of events unfolds. So what we're going to do today is answer that one question. What actually happens in those 200 milliseconds?
Okay, so the very first thing you need to get your head around is that when you ask for a web page, your request doesn't just get sent out in one big, neat message. Nope, the journey actually begins with a breakup.
That's right. The second you click, your request gets shattered into potentially thousands of little pieces. Instead of sending one giant slow-moving file, the system creates this agile swarm of tiny messages. It's kind of why a big image sometimes loads in chunks from top to bottom. You're literally seeing the pieces arrive and get put back together in real time.
And each and every one of those tiny messages is called a packet. The best way to think about a packet is like a little digital envelope. Inside, it's got a small piece of the website you want, your address so it knows how to get back to you, the destination's address, and, this is key, instructions on how to be reassembled with all its brothers and sisters when it gets there. So now we have thousands of these little digital envelopes ready to go. So where do they go? Well, they hit the road. Or, to be more accurate, they ride the light waves on a very real, very physical superhighway. We talk about the cloud, but the internet isn't some magical thing floating in the sky. It is a planet-spanning network of actual stuff. Our packets travel as literal pulses of light through fiber optic cables buried under oceans, as electrical pulses through copper wires, or as radio waves for our Wi-Fi and cell phones. And along the way, routers and switches act as the traffic cops, directing every single packet on its journey.
And this all happens at a speed that is, well, it's almost impossible to comprehend. A single data packet can literally circle the globe and come back to you in as little as 20 to 200 milliseconds. I mean, to put that in perspective, it takes you about 300 milliseconds just to blink. It's just unbelievably fast.
Now here's where it gets really clever. Your packets don't all take the same route. They navigate this complex, ever-changing maze. See, thanks to a system called packet switching, they're all sent independently. So if one path is totally clogged with traffic, or say a cable gets damaged, the other packets can just be rerouted on the fly. You've seen this happen. Ever been on a video call where it freezes for just a second and then suddenly catches up? That's your data packets finding a new, faster way home.
Okay, but in a global maze with billions and billions of destinations, how on earth does a packet know where to go? Well, for that, it needs to check the internet's master address book.
And that is the job of the Domain Name System, or DNS. We humans, we remember names, right? Like example.com. But computers, they only understand numbers, specifically IP addresses. DNS is that critical, invisible service that translates the name you type into the numerical IP address the computer actually needs to find the right server. All right, so our packets have an address, and they're zipping through this physical network. But to make sure they all communicate properly and get put back together the right way, they have to follow a very specific set of rules. The two main rulebooks are TCP and UDP. Think of TCP like sending a package with tracking and delivery confirmation. It's a little slower because it's double-checking that every single packet arrives in the correct order. This is absolutely essential for a web page, where one missing piece could just break the whole thing. UDP, on the other hand, it's all about speed. It's more like shouting a message across a crowded room. It's incredibly fast, but you might miss a word or two. When you're gaming online and your character stutters for a millisecond, that's probably a dropped UDP packet. The game just prioritizes speed over resending that tiny piece of old data. Okay, so let's put all these pieces together now. We can actually track the entire journey home and see how this incredible sequence creates that seamless browsing experience we all take for granted. So here's the play-by-play. First, you type in a web address. Your browser immediately asks DNS for the right IP address. Once it has it, your browser opens up a reliable TCP connection to that server. Then, it sends a request packet, basically saying, hey, can I have the files for this website? The server says, sure, and starts sending the website back to you, shattered into thousands of packets. Your browser catches every single one, uses their instructions to piece them back together like a puzzle, and just like that, the website pops up on your screen. Now remember that that entire process happens for every single thing you load online. Now zoom out and just imagine that happening all at once for over 4.5 billion users across more than 1.8 billion websites. The scale is just staggering, and it's all supported by a massive core infrastructure.
This is what we call the internet backbone. It's the collection of the main data routes between these huge interconnected networks. We're talking massive fiber optic lines running under the oceans, gigantic data centers, and these critical exchange points where different internet service providers, or ISPs, connect their networks to each other. The whole backbone is built with redundancy, with backups for the backups, to make sure the whole system stays online.
And, all of that massive growth creates some big challenges. The original internet address system, IPv4, only had room for about 4.3 billion addresses. In a world with smartphones, smartwatches, smart everything, we basically ran out. That's why we're moving to IPv6, which provides an almost unimaginable number of new addresses. We're talking enough for every single device, sensor, and smart toaster you can possibly think of for a very, very long time.
So after all of that, what's the one big idea to take away from this? It's this. The true genius of the internet isn't just its speed, it's its resilience. Breaking data into packets, routing them all independently, having multiple backup paths, it means the system was built from the ground up to withstand failure and just keep on working.
And that kind of leaves us with a final thought, right? This network, designed decades ago to survive major disruptions, is now the absolute foundation of our global society. It connects everything from our friendships to our economies. So as we continue to build more and more on top of it, it really forces us to ask, what does it truly mean for our future to be permanently online?